I'm going to tell you about the old and the new astronomers and how we changed, how we were a couple of years ago, basically, and how you are now. So we'll start with the old and then go into the new. So basically, this is sort of how astronomers were hundreds of years ago, and I picked specifically here Copernicus because I come from Poland, and Copernicus comes from Poland as well. So this is sort of how astronomers looked like in the 16th century. You can see a sort of a guy somewhere outside looking into the stars, looking very dramatic, and one quite important thing, which is there is no telescope there. In the 16th century, people were not using telescopes, so back then, you would think astronomers would always have telescopes with them, but in the 16th century, they didn't. The only thing they used was that wooden thing you can see on the right side. But already, even using such sort of crude instruments, they were able to find something interesting in the sky. So back then, this was the main work by Copernicus, De Revolutionitas Orbium Coelestium, which basically was a work that said the center of the universe is not the Earth, it's actually the Sun. Yeah, he had this amazing idea, which back then was quite revolutionary. And he did all that, all the calculations of where the planets and the stars are, basically just using this wooden instrument, not a proper telescope. It was sort of very crude science, but very revolutionary for that time. But this is something they were doing ages ago, and now let's go to how astronomers look like nowadays. So you can see here an astronomer at work in the 21st century, and you can see me on the right side.
Yeah. You mean the guy with the white shirt?
Yep, the white t-shirt, and just behind me is my supervisor, so the guy that actually taught me all the astronomy I know. And right next to him, there's another student, Ingo. So there's Ingo, Steve, and me. And as you can see, one thing hasn't changed throughout ages. Back in the 16th century, astronomers had to assume dramatic poses. And in 21st century, it's exactly the same. We still look very dramatic.
Okay.
And in here, I was actually controlling a telescope that was inside of a dome right next to me.
Oh.
And this is how the telescope looked like.
So we had a big telescope there.
Of a room and controlling on the computer a telescope that looks like that one.
Oh, okay.
And that's our telescope called Pirate, which Ismandi has seen during the conference. So there is our telescope, and inside it looks like that. So it's a remotely controlled telescope, which means that we can actually control it from our laptops or even from our mobile phones. Which means instead of sitting in the observatory, we can actually go out and meet friends and at the same time observe on a telescope.
Yes.
That's how much the astronomy has changed. And this is pretty much how images that we take look like. I know it's not very impressive, just a sort of a grayish smudge on a background. But if you do a little bit of work with such images, you can actually uncover how they really look like. So this is a galaxy M81, and then you can see here another galaxy, M101, which was photographed with the Hubble Space Telescope. And you can see it was photographed in a number of different colors, and then all these colors that you can see in the top left were then stuck together to form the image you can see on the right side. So this is how astronomical images you can find on the internet are really created. They're created out of small parts of the image, colored and then put together. And this is something I work on, which is extrasolar planets. So I don't even work with images, I work with dots. And I literally connect the dots. So this dot in here actually show me that there is an exoplanet, a planet, orbiting around another star. And that I can see in the middle, because on the left and on the right we can see a flat line, which means there is just a star somewhere in the sky. And in the middle, the star is covered by a planet.
Jacob, I think we need to enlighten them. What is extrasolar planet? I think we need to
so extrasolar planet is basically every planet outside of the solar system. And up until 20 years ago, we didn't know a single one. So we only knew 9 planets inside of our solar system. But for 20 years, we started discovering planets outside of the solar system. And to discover them, this is what we use. We look at stars and try to find exactly this sort of a shape. Dots that assume a shape that we call a bathtub.
So you said that extrasolar planet is a planet outside solar system, right? Aliens planet, you're trying to say that, right?
Mm-hmm.
Right?
And to find the planets, basically this is what we have to do. We have to look at brightnesses of stars and then plot them out as plots and then try to find if there are planets in our plots. So this is sort of what I'm dealing with in everyday in my everyday research. But this is the boring part of being an astronomer, and this is the interesting part of being an astronomer. As you can see, this is a screen shot from a BBC program that we took part in.
Oh.
So the BBC television came to our observatory and to start asking us questions, are there aliens in the universe?
Are there aliens
and
in the universe?
We were searching for... Yep. And because we were searching for planets outside of the solar system, on these planets there could be some sort of life, there could be aliens. So BBC television was making a film about aliens, and they came to our observatory, and you can see me there on the right, standing with a friend of mine, and we were operating this telescope and trying to show them a couple of planets. And
where is it? Jakub,
life out there.
Where is this telescope again? I think we missed the point.
Specifically, the one that's in BBC, you can see right now, is in London actually.
Oh, okay.
While the one I was showing you earlier, Pirate, was on the island of Mallorca.
I assume in Spain, I think? Mallorca?
Yep, in Spain, yep.
Sounds Spanish.
Yep, in Spain. Okay. While this one I'm showing at the moment is in London, in North London, a place where I studied astronomy.
Oh, okay.
So this is the interesting part of being an astronomer, which is that you actually get to deal with TV and explain to people what's out there in the universe. And just got a very quick question. How many astronomers do you think are there in the entire world? Try to guess.
Okay, what's the answer?
Million is too much.
Okay. A few hundred? How many?
150.2.
Are you sure? 300?
600. 600.
More than that?
2,000. More than world.
How many thousands are there? How are the astronomers in the whole world?
2,001.
10,000. So Jakub, okay, most of them said something about 10,000. Is that the correct estimation?
10,000? Right. Let me show you. So the map you can see on the right side is the city that I live in. It's the entire city, and it has 250,000 people living in it.
Okay.
So it's not the biggest city, but it's not the smallest either. And in the world, there are at the moment, according to our calculations, there are 17,000 astronomers.
17,000 astronomers.
On one hand, it's a large number. On the other hand, in the city that I live in Milton Keynes, this number is basically the number of people living in this tiny, tiny part of the city, the population of so-called Bletchley area. So that's just a tiny, tiny part of the town, not too much. So 17,000 is a really, really small number in comparison to how many people are there in the world.
Yeah.
So there are very, very, very few astronomers spread around the entire planet. Not too many of us. But let me show you something else about the stuff that I do. But I'll have to switch now to another screen. So let me just try and switch to another screen. So that's me again. So what you should be able to see at the moment, this is a map, a 3D map of all planets that we have ever discovered outside of the solar system. And let me zoom in first on the solar system itself. So the solar system is this one star in the middle that has a crosshair around it. So this is our planet, our whole solar system. And if I start zooming out, you should be able to see all these dots, all the red dots around our planet are basically planets that we have discovered in the universe so far.
Okay, what is he showing is our neighborhood, okay? Solar neighborhood.
So I'll try to move it very slowly. So you should be able to see now the entire universe rotating slowly with all the planets that we have found in there so far. And as you can see, there are over, in the bottom, it says there are 1,043 planets that we have already found outside of solar system. So that is a huge number. And many of those potentially could have life on them somewhere. Not entirely sure which, and we don't know which of these planets potentially could have life, but some of them definitely could. So, and this one, so when I go very, very, very close to our solar system, you can see every single one of these stars. I'll switch on their names. Every single one of these stars has a number of planets. And one of them, if you spot in the, now it's going to be in the center, very close to our planet, there's one called JG1214b. And this one is a planet that has, it's actually very, very, very small, and it's all covered in water. So instead of being a normal planet, it's just one big ocean. There's no dry land on it, there's only ocean. But right next to it, there's another one, which I'm going to put in the center in a second, that one, HD149143. And this one is actually a gas giant, a huge, huge, a planet even larger than Jupiter, super heavy and super hot at the same time. The temperature on this planet is about 2,000 centigrade. So it's a super hot planet that is basically being vaporized by its dark star. And in this system, GL581, which I'm putting in the center at the moment, we have a completely different set of planets. So there are 5 planets in that system. Like in our solar system, there are 8. And in this system, there are 5. They're all orbiting around its star. And some of them are actually as small as Earth. So potentially, maybe there could be life on some of these planets. We don't know yet. It would take about, as far as I'm concerned, 18,000 years to fly to this planet, even using the fastest rocket we have at the moment. So it would take generations to get to this planet and check if there's any life in there. But who knows, we might be able to invent new technology and in the future actually get to these planets. Right, so I'm going to zoom out now, switch on the text, quickly rotate it for the last time, and I'll get back to you now, show you back myself in case you have any questions.
So, you have any questions? Anybody? Okay, who has any questions? Okay, you want, okay. Come here and ask him some questions. Okay,
slowly.
Okay, show yourself. Can you turn on the light?
Hello, yeah.
Yeah, okay, this is the guy. Okay, can you introduce yourself? Hey. My name is Justin. My name is Justin.
With you?
Hey.
Nice to meet you.
Hey. I have one question for you.
Sure.
Have you been to space?
Let's say that is a good question, because on one hand, I've never been to the outer space. I've never been in a vacuum. On the other hand, we're all in space. You cannot escape from space. Every single one of us is a part of the universe, which means a part of space.
Oh.
So actually, we're all in space right now.
Oh, technically.
Technically, we're all in space, yeah.
Oh,
But no, I've never been to space. I would absolutely love to go. So if you guys building a spaceship somewhere over there, you know, reserve a place for me, because I would love to be able to fly to space.